Hello and welcome to the very first EC290 Video Homework Solutions Guide. I'll be starting with problem 2 because I'm fairly certain you don't want to watch me solve problem 1. So to start, we want to look at the solution strategy for how we're going to approach this problem. And so as we notice, we're going to be converting 3 different numbers from decimal to binary, octal, and hex. Now, when I approach this problem, first thing I think is, well, I know how to convert from binary to octal and binary to hex very easily. I just have that very easy methodology of just parsing the number into either 3-bit sections or 4-bit sections, and then just finding which binary number that is, or octal number or hexadecimal number that is. And then, so really, essentially all this problem is asking me to do is convert from decimal to binary. That's the hardest part. And so, that's what I'm going to do, and the way I'm going to do that is by first looking at this number, 42, and thinking about how many powers of 2 fit into it. So we're going to go through this a little bit more systematically on a separate sheet of paper. So I have 42 in base 10. And so I want to convert this to binary. I can think about different powers of 2, and so, well, this is smaller than 64, but bigger than 32. So my first power of 2 that I want to look at is 32. So since I know 32 fits into 42, I'm going to put that there, and I'm going to subtract off 32. Now 10. Well, my next power 2 of 16. 16 is bigger than 10, so that's going to have to be 0. Now I've got 8. 8 does fit, so I'll put a 1 and subtract this off. Now I've got 2, so 4, that's too big. 2, perfect. 2 minus 2, 0. And then we don't need anything at the 1. So my number is going to be equal to 1, 0, 1, 0, 1, 0 in base 2. Now I can do something very similar with part 2, but since it's almost identical, we're just going to skip from 2 to problem 3, and you'll be able to see the final solutions in the PDF form at the end. So we want to solve or convert 12.125 to decimal, from decimal to binary. And so first thing you want to do is figure out 12. Well, it's smaller than 16, bigger than 8. So we're going to start with the power of 8, 1, and we're going to subtract off 8 here. And so we're going to come down to 4.125 in base 10. Now we've got 4. That fits perfectly. So now I subtract off 4. Now I've got 0.125. So now I can skip all the way down to the radix point. So I got 2, 1, the radix point. Now I've got here is 1/2, which is 0.5. That's bigger. And then I've got 0.25, which is 2 to the negative 2. That's also bigger. And now I've got 2 to the negative 3, which is 1/8, so 0.125. That's a perfect match. And so we are now done converting this from decimal to binary. So this is in summation 1100.001 in base 2. Now, to complete the second part of each problem, let's go back to part 1. And now we want to convert this from binary to hex. So first thing I notice is for hex conversions, I want 4-bit chunks. Since I only have 6 bits here, I'm going to need to add some leading zeros. So this is, again, equivalent to 0, 0, 1, 0, 1, 0, 1, 0, base 2. I'm going to put our little dividing line there. And so this is 8 plus 2, which is 10. which equals A in hexadecimal. So I've got A, base 16, and 2. And now I've got my hex. Do a similar thing with this number. Again, I need 4-bit chunks, but here I don't want to add leading zeros, I want to add trailing zeros, because any extra zeros after the decimal point, or sorry, radix point, doesn't add any value to it. So we're going to alter this slightly to 1100.0010. And we've already got a natural division line, and so this is 4 plus 8, which is 12, which is C, 0.0010. So, and surprisingly enough, we can keep that, so that's 2 16ths. And I'm going to stay with this one, and we're going to convert this to octal. And here we've got a 3-bit chunk, which is what we want, but here we have 4 bits, so we want to extend this with leading zeros up to 6 bits. So this is my octal conversion. Put a little divider line in there. 001 is 1, 100 is 4, 001 is 1. And that's the full solution to part 3. And to do this one last again, so we've got 6 bits, so we just need to keep this. And we'll put a little divider. 4 plus 1 is 5. This is 2. And that's our number in octal. So now moving on.